Hi everyone, welcome to Observability Guru. Today we're going to discuss about Observability Maturity Model. Observability Maturity Model, or generally a maturity model, is a way for us to identify where are we in based on a particular framework and uh, kind of like help us to move into the particular destination we want to reach. So when it comes to observability, there are a lot of things we would like to enable, like logs, metrics, traces, and other things. And sometimes some of our teams are struggling to understand where to start and where we're going to stop, or what is our destination. So today we are going to discuss something which is little focus on AWS and trying to understand what is a observability maturity model and what are the elements of that. And this model you are able to see now is having around 5 levels. So level 1, we call it keeping lights on, which is about ensuring that we have the bare minimum. And level 2, which is about making our systems observable, which is about enabling deeper insights, so that we are not just keeping lights on, but we are moving towards having more data points which can assist us to identifying things much faster and resolve things much faster. Level 3 is about enabling correlation, bringing a holistic view so that we can pretty much isolate issues faster and resolve things much faster as well. And level 4 is about leveraging AI so that we can improve our detection with AI ML modeling, doing anomaly detections or forecasting and other things. And the final level of my model, we are looking at trying to build autonomous capabilities into our systems. So this is about making our systems self-heal, or systems able to remediate things by itself. So in nutshell, this is the AWS Observability Maturity Model, and I truly believe this allows anyone trying to understand where are they as part of this model and then go through with this journey. It will help you to improve observability in your system, and that naturally will result in increasing high availability, reliability of your application. So moving on, let's look at level 1, which is about keeping lights on. At this level, our predominant focus is enabling the bare minimum, which is about building infrastructure monitoring and using synthetic monitor to just to check whether the application or your system is up and running, and then build alerts based on these availability monitors. So this is just to ensure we do some basic sand test and we monitor infra, and then we are able to monitor the availability of our system. We can leverage AWS services like CloudWatch for infrastructure monitoring, and we can use AWS CloudWatch Synthetics to enable synthetic monitoring. Synthetic monitoring is nothing but recorded journeys mimicking actual production and user journeys. So this way we are simulating continuously what is a typical end user will do in your system, and in case if it comes across any issues, it will alert us. So it's a great way to be little proactive. And then we will build our monitors or the alerts based on this availability centric things. So this will enable us to ensure we keep the lights on and we get alerts whenever there's issue. So one of the challenge in this level is we'll probably not be able to identify root cause. In case of issue, what has caused it? We might get informed something has gone wrong, but why? It's a missing piece. So this we are trying to enable with moving into level 2, which is about building observable capabilities. And here we will first trying to enable APM, application performance monitoring, and we are able to leverage things like X-ray or even integrate with OpenTelemetry to enable APM. And then we'll try to standardize logs. We can use AWS CloudWatch logs or AWS OpenSearch, and making sure we standardize logs and we try to get the best when it comes to logging. And these two will enable metrics which are correlated with our system performance, which will allow us to understand the internal system state, and also it will allow us to understand what is happening from a business perspective. So these are very good things which will allow us to identify what has caused this issue, because we have monitored, which is about keeping lights on level 1. As I told you, level 1 is good. It will let you know that something has gone wrong in your system, but you will not be able to figure it out easily what has caused this failure. But if you implement this APM, the logs, and we enable metrics, we pretty much able to understand internal states of our application or the systems, and this allow us to identify root causes fast. And we can always go and enable runtime code performance. We can use things like AWS Code Guru, which will try to let us know the resource utilizations and other things when it comes to our code. And then with this we can standardize our alerts, so we can build lot of alerts which are business centric because we have the metrics. We can build lot of standardized alerts which are greatly correlated with end user experience because we have the traces. We know we have more drill downs, and we can understand what is our code doing. So in that way we can improve those typical availability based alerts in level 1 to more standardized alerts which are correlated with our system internal state and more correlated with what is our end users are experiencing. And at this level, whenever there's a increase in capacity, or because we are in cloud, it's about scalability, and the things can scale pretty much faster. So we want to develop observability as code accelerators, so things are not happening manually, or it can we can write these enabling observability and other things as part of code, and it can be part of CI/CD pipelines, so it can move from one environment to another until we move into production. So we have consistency as well, so we can get all the good benefits of writing a code. So that we call observability as code solution. So the observable or the deeper insights level 2 state will allow us to leverage this, the traces, the logs and metrics, and then build lot of meaningful alerts. And then once these alerts trigger, it will help us to isolate our root cause much faster than level 1. And moving on, the level 3 is if you follow me through. So we have the level 1 which is keeping lights on, and then we had the level 2 which is about making things it's about observable, the deeper insights. And I told you that we are at better position when it comes to identifying root causes. But one of the challenge at that level is we have a lot of data. Level 1 we never had much data. It's you get alert when something is down, or something is horribly wrong. But level 3, we are able to identify the internal system states. We have the metrics, we have the logs, we have the traces, and now we have the things we are getting from level 1 as well, which is about our the infra alerts, which are about our synthetic alerts, the basic availability based alerts. So we have a lot of data, right? So we can be 100% sure within those data we have the root causes, we have the reasons why something has happened. But can we identify this root cause quickly? Because it's with multiple data points. So how we trying to uh, understand and eliminate this noise? So that's what we're going to do part of level 3. We want to correlate things so that whenever we have more data points, we are able to quickly correlate, bucket some data, and then we can quickly see where the issues are happening. So at this level we are doing couple of things. One is we are trying to enable RAM, which we call real user monitoring. We can use AWS CloudWatch. So this will allow us to observe exactly the front end user performance. So or we call it browser performance. So what or end user performance. So we can have understanding what actual end users are doing when it comes to anything and everything. The every interaction point we can see with RAM. And we also are going to leverage service maps. It will be part of our APM. So once we enable APM, we will the X-ray, AWS services, and OpenTelemetry will give you us this service map, and this map will allow us to go with a topology. It generally is a time-based topology, so we can go back in 5 minutes, 10 minutes, 15 minutes, understand what has changed. So this way we are able to correlate things much faster, and then we are able to isolate issues much faster. And one important thing is we are going to go beyond standardized alerts and develop alerts correlated with SLOs. Before that, of course, we have the metrics, we have the data, so we need to define our service level objectives. Every application, if you want to improve reliability, you have to define what is good mean. So good is not debatable, it is well defined. So what we do part of service level objective is we will define what is good means, and then we can develop alerts based on that, and we call this more of a customer experience driven alerts. And this way we will get alerts directly related to customer experience, and when the experience is degrading or breach. And this way our mean alerts are more or less very actionable, and there's less noise, and we will have this correlation capabilities with the topology based service maps, which will allow us to isolate root cause much faster. And we can use CloudWatch to develop SLOs, and if you are using AWS application signals, you can automatically get SLOs enabled as well. So at this level what we are trying to achieve is we'll try to identify root causes and important detail as quickly as possible compared to the level 2. So at level 4, what we are typically trying to do is bringing in AI. So we want to do metric anomaly. So instead of having threshold based predefined alerts, we can develop anomaly based alerts. We can look at anomalies, and that will allow us to pretty much be proactive, and we can be predictive as well. And we can look at log anomalies, and we can example if you do a deployment and if suddenly a new exception start appearing in your logs, probably your DevOps teams or the SRE teams was not aware, you don't have a trap until you get to know and you define it. And that's one of the challenges and one of the drawbacks of traditional monitoring, or the rules based or the static based approach which you are following. But with log anomaly, which AWS CloudWatch is providing, we have the capability of understanding what's new happening, what's outside of our baseline is happening, and what exceptions have start spiking going beyond the baseline, and we will be on top of our game. And then we can use AWS services like AWS Forecast to do AWS metric forecasting, so we can figure it out when are we going to run out of our service level objectives, or when are we going to uh, breach our contractual obligations as well. So all of these things will really help us in being more predictive and help us being more on top of our operations. And this all will help us cutting down noise, and then trying to getting into the root cause much quicker. And also on top of this, we can use things like DevOps Guru to use AI ML capabilities on top of services. It can be tag based, or it can be service based, or it can for your entire account, so that we can get that benefit as well. And then finally, we can define rule based resolution workflows leveraging AWS Lambda or the systems manager. So when something is failing, we can have some sort of automation in the backend which is able to go and fix it without our involvement. So that's typically automation. And what I like to tell you is, so this is more of like AI will do the intelligent alerting. It will identify things much faster, it will identify things much quicker, and sometimes it will identify things before even we encounter issue. It will know that we are in the wrong path, and we will come across a major issue, and we can be on top of that, and we can use some automations to resolve or remediate these issues. So I call this more of a predictive approach and being proactive. And finally, level 5, it's about being autonomous. So it's about leveraging what we are getting up to level 4, which is your intelligent alert, like which is your anomaly based metric anomaly based alerts, anomaly based logs alerts, customer experience driven alerts, using metric forecasting to understand when are you going to reach out your error budgets and other things, so that you are truly improving our alerts. So if you remember, we used to have availability based alerts. We standardize with logs metrics and the logs metrics and events and traces, and more meaningful alerts which are correlated with end user our end user experience and the system internally status. And then we use correlations to identify things much faster and reduce the noise. And then after that, what we did is we use AI to get the intelligent alerts, and we had some rule based backend which is doing the automations and which is doing fixing part. At level 5, we want to come out from that rule based approach and really use generative AI, so that whenever these intelligent alerts are there and our application is able to understand and it's able to make sense out of this data, and then come up with solutions to resolve issues by itself. We call it self-healing. So we are able to use generative AI to enable self-diagnostics and then self-healing capabilities. So this level applications or the systems can withstand failures and able to self-heal themselves and be typically autonomous. So come back to my observability maturity model again, just to give a quick overview. So we have monitored, which is about keeping lights on, and then we have observable, which is about deeper insight, metrics, logs and traces, and standardized alerts. We have correlated, which is about using service maps, topology, using time-based topologies, enabling real user monitoring, and developing service level objectives and XLA based alerts, so that we are very end user centric. And predictable, which is at our level 4, which is about using AI, metric anomaly detection, log anomaly detection, metric forecasting, and typically do noise reduction. And we can use things like DevOps Guru to look at our entire platform. And then we have rule based resolution workflows at backend. Based on the alerts and failure points, we can automate things. And this is a very advanced stage where we are very proactive. And finally, we will be at autonomous, which is about self-diagnostic and uh, self-healing. Right. So all of this, what will do is this will provide you a I mean, if you are starting new, you can start from keeping lights on level 1, and then you can go through this journey. I'm not suggesting every application has to be at level 5 or level 4. Depend on your application, business criticality, end user, the end user involvements, and various other factors. You can decide where you want to be in this maturity model. And if this is an existing application, you can baseline your application which maturity you are currently at, and then you can figure it out what is your end goal, where you want to be, and then you can start moving in that direction. So this will typically ensure that we are able to we can improve our mean time for detection, we can improve our mean time for resolution, and of course we can improve our service level objectives and end user experience and those things. So thank you very much for spending time. I'll meet you soon.